Hi, everyone. I'm Lindsay Jones, co-chair of the Executive Board of Theatrical Sound Designers and Composers Association, and I want to welcome you all to this seminar on panLab Console. We are super excited to have this today, and we're glad that you can join us. If this is the first time that you are attending a TSDCA seminar, we're very glad to have you. Theatrical Sound Designers and Composers Association is an American-based organization for sound designers and composers for live events in America. And if you would like to learn more about us, you can check out our website, which is tsdca.org/membership to learn more about membership options with us. We accept sound designers and composers as well as people in live audio. So if you're an A1, A2 engineer, or other person interested in audio, we're super excited to have you. Please feel free to check us out. Without further ado, I'm going to turn things over to Dan Higgett, who is the leader of Innovate Audio, as well as a professional sound designer based in the UK. Dan, thank you so much for staying up late with us here. I know it's super late where you are, but we really appreciate your time. And so here's Dan Higgett with panLab Console.
So yeah, thank you so much for having me. My name is Dan Higgett, and I am the director and founder of Innovate Audio Limited, and we are the creators of the panLab line of spatial audio processors. So so a little bit about me. So my background, as Lindsay mentioned, is as a live theatrical sound designer and engineer. Been in the industry for around 20 years. And in that time, I've also worked quite a bit in immersive theatre and in the UK for a larger immersive theatre company called Secret Cinema over here, who create these big immersive theatrical worlds based on blockbuster films. So we would do things like work with people like Baz Luhrmann to create an immersive theatrical experience based around Moulin Rouge or Romeo and Juliet, where the audience would we'd build these big sets and the audience would experience the film from sort of within the film as itself. So Moulin Rouge, we would build a replica of the Moulin Rouge Club, and the audience would experience things that would happen within that club as part of the experience. So my kind of background in immersive theatre led me to sort of see that there was a bit of a gap in the market for a spatial audio solution that really worked for the kind of projects that I was involved with, both in immersive and standard theatre, and also in kind of live events as well. That was the real limitation that I didn't, the need that I felt hadn't been met was really the speed of the setup process. We were creating these worlds in sort of warehouses where you'd be completely up against it time-wise, and there'd be no opportunity to deploy one of the more complex spatial processors that were out there on the market. So this initially led me to create panLab, which is now in its third iteration, and now panLab is a spatial audio processor that essentially adds spatial audio capabilities to QLab. So you can spatialize QLab audio cues onto QLab cue outputs. So that's the sort of background of the panLab line of processors. But in speaking to people at webinars such as this or other designers, when I'd be introducing them to the software, quite often the question would be asked is, this is great, but can I work with live audio with this solution? And so panLab Console, which is a new product that we've just launched here in the UK at Plaza a few weeks ago, is our answer to that question. So it takes our concept of applying our bespoke spatial algorithm and applying it to QLab, and instead now applies that same algorithm to a whole selection of mixing consoles. So you can actually add spatial audio functionality directly to mixing consoles. So what is panLab Console? It's actually a 3D spatial audio processor. So this is a step up from panLab, where we were always working in 2D. panLab Console actually adds 3D, the third dimension, into the algorithm and also into the user interface, so we can actually quickly work with 3D spatial audio. Central to the whole concept still is that simple 5-minute setup. So anytime we add any kind of feature or make any change to any panLab related software, it's always up against the benchmark of could we still set this up in 5 minutes? We're very hopeful that that's still the case. And it's actually rendering the spatial audio directly onto the mixing console. So it's using the hardware that you're already using on your production and rendering the spatial audio directly there. So by the end of this webinar, we're hopeful that you will be able to understand the key concepts and terminologies that you would meet in panLab. So I'm just moving some Zoom windows outside my QLab screen. We're hopeful that you'll understand the full feature set of the software, and we want you to be confident in deploying panLab console on a project. So let's get straight in because there's quite a lot of stuff to cover. First of all, let's have a look at what a typical spatial audio workflow looks like. So typically, you'll have a mixing console that you'll be using to mix your show. You'll output from that mixing console stems or post-fade direct outputs into some kind of spatial processor. That processor will essentially use its own bespoke algorithm to render those inputs onto a whole set of outputs that go out to loudspeakers. You'll also need some kind of controller that will typically live on a computer that allows you to actually move those objects around in the processor. So there's some fantastic solutions that do this really well. As I mentioned before, the key drawbacks is the time it takes to deploy them. With some of the kind of wavefield-based synthesis processors out there on the market, you could be looking at a 12-hour session or an overnight session to actually deploy one of these spatial audio solutions onto your project. And that's because you need to know the exact XYZ coordinates, very accurately, and you need to know that the dispersion angles of speakers and all that kind of detail. And you need to have home runs to each of your speakers, and it just becomes a very laborious process deploying them. So we kind of asked ourselves, could we create a spatial audio solution that does away with that spatial audio processor and that you can set up in 5 minutes? And that is really what panLab Console is. So here's the panLab Console workflow. We get rid of the spatial processor or the hardware spatial processor entirely. The mixing console is the center of your gig. You output from the console to your speakers, and panLab Console acts as both the controller and the processor. You'll notice that no audio actually passes through panLab Console. We're purely sending control data to the mixing desk itself in order to render the spatial data actually on the console. So let's touch a little bit more about how that works. So here is a channel strip on a mixing console that we'll call source 1. It's got 4 auxiliary sends that go out to speakers 1 through to 4. And essentially all we're doing is applying our amplitude-based panning algorithm directly to the input channel to auxiliary send levels. And we can output high data volume to the console and update these in real time very quickly in order to actually spatialize input channels onto output channels, essentially. So I'm guessing if you're here, you're familiar with the standard definition of what a panner is. So if I talk about a panner, I might be talking about a quad panner that would be 4 speakers, 1 on each corner, or a 5.1 or a 7.1 panner. We've actually kind of taken that one step further with the panLab series, and we've created this concept of a zone. And a zone is really key to that 5-minute setup because it's how we work out the relationship between all of the speakers in the zone. So we ask you, the user, to place your speakers into zones. So a zone is kind of like a panner, but instead of being a square, a 4-sided shape, the shape of the zone is the shape of all of the loudspeakers that are contained within that zone. So it's a polygon shape, so you can place all your speakers onto the panner wherever you want, and essentially panLab works out the shape of the zone based on where all the loudspeakers are in a zone. So it's kind of like a panner on steroids. One of the really important things that we do when we place all the speakers into the zone is work out the geographical center of that zone. So what do I mean by that? If I've got a piece of paper like this, and if I put my finger under the piece of paper, the geographical center or the center of gravity is where that piece of paper will balance neatly on my finger. And so part of our algorithm is actually working out that geographical center. And therefore, it allows us to work out the relationship between all of the speakers in the zone. And that means that if you place a source or a sound somewhere within that zone, we can work out the nearest two speakers. So in this instance, because the source is towards the edge of the zone, we can work out that we need to pan that source between speakers S1 and S2, because it's kind of in the middle of those two speakers at the edge of the zone. And it also means that when we move the source towards the center of the zone, we can spread out that source until that source is distributed to all of the loudspeakers in the zone. So that's a key bit of concept that we've introduced into the panLab range is the concept of zones. Another feature of a zone is that we've got this concept of a zone boundary. So when you've got the sound within the zone itself, the sound level is normalized to a constant amplitude, so it's equal power panning. And what you can do is actually move the sound out of the zone and away from the zone. And when you do that, the sound level to that zone decreases over space. And this is something that concept that we introduced back in panLab 2. And the really powerful thing about it is it allows you to layer multiple zones together on top of each other. So as my background's in theatre, and I think yours probably is as well, I always use the example of two zones being the auditorium zone and the stage zone. So these are sort of two panners, as it were, or two zones that you can layer on top of each other in the panner. Essentially it allows you to move a sound object all the way from the back of the stage in this example, all the way across, cross-fading between those two zones over the boundary and into the auditorium zone. And that's a basic example, but it allows you to build up, really complicated panners, essentially, just by layering lots of zones together. So panLab console actually adds that third dimension into the equation, and to deal with that, we've come up with the concept of stacks. So a stack is a vertical stack of zones, and you can have as many zones in a stack as you want. And if we draw it here, we're actually looking at this from the side, and this is three zones stacked on top of each other in vertical space, in 3D space, zone A, zone B, and zone C. And this is literally what you're able to do with panLab console is place a source somewhere on that vertical axis as well. So in this example, if we place the source between zones A and B, we'd sort of be distributing half of the output power to zone A and half of it to zone B. If we were to move that source down to zone B, now all of the energy of that source is being distributed to zones B. And if we were to move that source down again to close to zone C, most of that output energy is going to be going to zone C. So I think that's enough with the slides. Let's introduce you to the software and show you around. So this is now a live demo. So let's hope that all goes well. This is actually the current released version of panLab console. It's just version 1. This is actually a beta of version 1.1. And I wanted to show you this because we've made a load of big advancements to the OSC and MIDI implementation to actually remote control objects that it'd be great to show you and get some feedback on, hopefully, about the sort of direction of travel we're going in. So when you first launch a panLab console file, the first thing you need to do is link it, associate it with a particular model of mixing console. Essentially, basically just to have an understanding of how many inputs and outputs that we can process. So At the moment, we support 19 models of console, the Yamaha QL series, CL series, and Rivage series, along with the X32, M32, and XAir series consoles. So if I had a QL1 here, I'd be able to spatialize 32 inputs onto 24 outputs. If I had a Rivage series, that would go all the way up to 288 inputs onto 108 outputs. Now, at my house here, I've got an X32 rack, which allows me to spatialize 32 inputs onto 16 outputs. So that's what we're going to connect to today. In order to actually manage the connection, I just need to know the IP address of the console that I want to connect to, and hit enter. And then essentially we're just asked, we're hopefully presented with this successful connection pop-up, and we're asked whether we want to sync the channel names to or from the console, which is a fairly familiar concept if you've connected to any console over the years. So I can actually work offline, and panLab console is actually free to use offline. So I could build a show file essentially with all my channel names offline and import them into the console like this. But in this occasion, this is a completely new blank file, so we're going to pull the channel names from the console. So this is the main user interface we call the soundscape window. The central panel here is our panner that we're going to fill with objects very soon. The left panel here is essentially lists of all the available objects in the file. So it can be a list of sources, which is denoted by this little microphone, or speakers, which is the speaker symbol, or snapshots, which I'll come to later, but is a way of automating objects around the space. So you'll notice that when I change these tabs, the actual right panel as well changes, because the right panel is an inspector panel, and it's basically an inspector of whatever the currently selected object is. So that's just changing with the selection. So first of all, we need to add, what we'll actually do is add a backing image to the panner so we can see where we're placing things, and we need to add some speakers and sources to the panner. So there are three tabs essentially. There's the main soundscape tab in the toolbar up here. We've also got a source manager, which again is going to be a list of sources, and a speaker manager. And the speaker manager, you'll know that we've kind of got three columns of lists, and that's because we've got stacks, and you can have multiple stacks in a spatial environment. Each stack has got some zones in it, and each zone have got some speakers in. Before we add any of those things, we're just going to add a backing image. So if I go to this little cog at the top right here, I can get access to the file settings, which is all stuff to do with OSC and MIDI and timecode inputs that we can have a look about later. But right now we're going to use it to set a background image for the file. So if I click on that little icon, I can find a background image, which is literally just an image file that I've got on my computer that's square, hopefully. And we can import that into the file. So if I hit done on that, if we go back to my soundscape now, that you can see that we've got this plan image on the background in which we can place our speakers and our sources. So let's go and play some speakers. So I'll head back over to the speaker manager. The file, when we create a new file, has given us a stack and a zone essentially for free, because almost all the time you'll only need one stack. Most of the time you'll only need one or two zones, and you'll need some speakers to add to them. So it's given us our first zone essentially, because we'll definitely need one. And if we hit this add speaker button, you'll see that we've added our first speaker. It's pulled its name from its associated console output, so we can associate it with any of the available console output channels. It's picked the first available one, which I've already pre-labeled all of these for ease, so it's just pulled the name in. So if I just hit the add speaker button a few times, I can add all of the speakers that I want in this first zone, and they're all turning up here. Let's place them back on the soundscape. So if we go back to our soundscape tab and head over to our list of speakers, we can just drag and drop them onto the soundscape. So this little icon here just denotes that we need to actually drag and drop that onto the soundscape to start using it. So I just thought today, for this example, the sort of multiple hangs of speakers across the front of the stage is quite a popular way of spatializing sources on the stage, and we can do that with panLab console. So I thought I'd give us, instead of a stereo front image, I could give us a sort of hang of 5 different speakers across the front of the stage. And because this zone needs to have some weight, have some volume to it, because this is just a line essentially at the moment, we'll add some side surrounds and some rear surrounds, and that will just give the panLab console algorithm just a little bit of an idea of what the shape of this zone is. So because we've got speakers around a sort of central position, as you typically do in an auditorium, panLab console will be able to work out the geographical center of this zone and pan sounds accordingly. So let's put our rear surround back here a little bit and get all of this set up. And let's add our first source, which is essentially a console input channel. So we'll go over to our source manager and hit add source. Now, you can actually work with either mono sources, which are just one input channel, or you can actually work with multi-channel sources all the way up to 8 channels. So that could be a 7.1 source, for example. For the moment, most of these are just going to be mono sources. And again, they just link to the first available console channel, which for this demo, I've just called drums. So if we come back onto our soundscape window and go to our sources list, we can drag the drums onto the panner here. And let's actually see what's going on. So if I move my window up here, we're connected to an X32. So this is the drums channel input to outputs routing. So you can see that if I move my drums back behind that center channel, we're now essentially just routing to channel 3, which is the center channel. If I move it over to the left of center or the far left channel, you can see that my output routing is adjusting accordingly depending on where that source is. If I move it in front of the PA, you can see that the spread of that sound is starting to spread out, with most of the energy going to the central channel, because that's where I am, and some energy going to the other channels in that front array of speakers. And I can move it further back, and I can start moving into the side surrounds and the rear surround, and finally that's rear. Oh, actually, I've got these the wrong way around, haven't I? That needs to be rear center there for that to make any sense. And finally back into that rear center channel there. So, within the space of a few moments, we've essentially created a fairly complex spatial environment that we're now live routing our audio to, which is pretty cool. But let's make this, one bit better and start working in 3D. So if I go back to my speaker manager, let's add a new zone, and let's just call this the height zone, which I'll just type out. And we can add some speakers to it. So I've pre-labeled our next 4 mixes, overheads 1 through to 4, and go back to my soundscape window, and I can drag these onto the panner as well. Let's say they are here, here, and back at the back left and right. So we need to give these speakers some height. So if I just click anywhere on the panner that isn't an object and drag around, we can move our whole view around in 3D, which is pretty cool. And then we can actually just drag one of these speakers up, and they all move together. So we've now created an even more complicated spatial environment with the height axis. And we can do things like move the drums up into our overhead channels. And again, so if we look at what's actually happening on the console, when my drums are down here at the ground level, essentially we're in our main system. And as I move my drums channel up, you can see that the energy starts being distributed into my 4 overhead channels, which are here, almost the final channels. And I can move it forward into the front overheads or back into the rear overheads. So quite quickly, again, I've just created that 3D spatial environment that I can use to manipulate my sound objects. Let's move the drums back down there for the moment. I can always click on this little home button here, and that will always reorientate me back in the middle. So let's just check the zone boundary. So if I click on one of these speakers in the bottom zone, I might just want to make, well, first of all, let's just make the zone boundary really small so you can see how it's visualized. And do the same thing for the overhead zone. So if I make the zone boundary really small, you can see, in fact, we'll just show you. So because we're within the zone, we're normalizing to a constant level. If I move these drums outside the zone, because the zone boundary is now tiny, the levels that send to those drums are now dropped off to nothing because we're outside the zone. If I, let's turn that zone boundary all the way up, and now you can see that that entire level of this spatial environment is now going to be essentially one level, and I can essentially just move my drums out of the zone, and we're always going to be normalized to pretty much a constant level. So let's reorientate ourselves back at the top, and what I can also do is just turn this visualization down. Now we're happy with how everything's set up, and I can also even just hide these overhead speakers if I feel that they're going to get in the way of the view a little bit. So let's place the drums back on stage. Let's plop them there, and let's add some more channels. So we'll go to our source manager and add some more sources, because we've got a whole band to add here. So we've got some bass, guitars, some vocals, some backing vocals. These are all mono channels, so I can just click enter, and essentially they're linked to the first 8 channels on the console. And channels 9 and 10 are actually keys left and right, so I'm going to add a multi-channel source with 2 inputs that I will label myself as keys, and this is assigned to channels 9 and 10, which are keys left and right. So we can just quickly go back and add all these onto the panner. Let's put our bass on the stage there, and our guitars over there, and maybe I'll have our lead vocal forward a little bit, and our BVs forward a little bit too. And where are we going to put our keyboard? Let's show you the keyboard first. So this is a multi-channel source. So if I zoom in on it and show you, we've got this direction handle which allows us to move the position of our left and right objects on the panner, and position the left and right objects independently of the main objects, so we can essentially render this stereo source onto our soundscape. So let's move our keys over here. So the left channel is, well, it's left to the center, so the left channel is going to be on the center channel, and the right channel is going to be at the right. So we've built our soundscape, we've added all our source on, we're sort of spatializing everything, and we're sort of happy with how things are mixed at the moment. So this is great. What we need to do now is automate some things. Before I actually start automating anything, I'm just going to draw your attention to the kind of automation scope, so which is all these little checkboxes here. So by default, all new sources are set to be recallable by snapshots, but we can also optionally make them recallable via OSC and MIDI. So I'm just going to click down here. Actually, on the to-do list for this version is allowing multi-selection, so I can just do all of this at once, but for the moment, this is how things are. So just for the purposes of this demo, I'm just going to enable recall for all parameters for all sources. The other thing we can do is just isolate channels. So if we don't want a channel to be recalled by anything, I can hit the isolate button, and that will just take that channel completely out of recall. But for the purpose of this demo, we're just going to allow all channels to be recallable by everything. So let's head back to the panel. So we've shown you the source tab here and the speaker tab, and now it's time to just introduce you to the snapshot tab. So a snapshot, I mean, let's say this is a gig and we've got different songs, so we can add a snapshot for each song. If I hit the add snapshot button, let's call this song 1 originally, and let's move some objects around. Let's say in the second song our BVs come out a little bit into the side surrounds, because that's what we want, and we can add another snapshot that's called song 2. So now if we select a snapshot and hit recall, all of our objects are going to move back over the designated time, which you can set as a duration here, and then you can recall again a snapshot into the to the next. You can recall the next snapshot as well, so you can quite quickly build up, different scenes in your show where all your objects move to the desired locations. With snapshots, there's also quite detailed recall scope, so you can actually turn on and off the recall scope for individual objects, for individual snapshots, which you can set here, and you can view what parameters are going to be recalled by the snapshot here as well. Snapshots can be recalled remotely by OSC, MIDI, and timecode inputs, which we can talk about a little bit later. The other inbuilt form of automation that we've built into panLab console is sequences. And this is, again, a piece of technology that's carried over from the original panLab line, which is sequences. So if we select an object on the panel here and move back over to our sources tab, who should we automate around? Let's automate our guitar. Let's say in the next song we want our guitar to circle the auditorium here. We can select the guitar, and on the right, along with all of the level controls that we've got, we can also add a sequence. A sequence is associated with a sound source, so we can add a sequence in this right panel here in this kind of inspector to do with the sound source. So if I hit the Add Sequence button, you'll see that we're prompted to move the object to record the automation. So if I start moving, you'll see that we start drawing this vector path as a trail behind the object. So let's loop it around the auditorium and join it back at the beginning. And now, yeah, so if we, well, we can name our sequencer as well. So let's call it Circle the Auditorium. And we can recall that. So you'll see that it's following not only the position, but also the timing of my slightly jaggedy mouse as I moved it around the place. And it's going to loop back and join at the beginning. If we liked that movement, but we wanted it to be a smoother movement rather than the exact movement of my mouse, I can actually just change this duration. Let's make it 15 seconds. And we're prompted to either change the duration by changing the object so it's a constant speed of movement, or adjusting it proportionally. So if we change it to a constant speed of movement, now if I recall this again, you'll see that we've got a much smoother movement of the guitar as it goes around the circle. We can change the height of that, and we can change the XY coordinates of that path as well. So we can recall that now, and now you'll see that the guitar is slightly higher up in the air, so it'd be more into the overhead speakers. And we can also loop the sequence. So if we hit the loops button down there, now this guitar should just carry on looping round forever and ever until we stop it. So you can have that as a sort of a nice effect that's going on during the song. We can also assign sequences to snapshots so that the sequence is recalled when you recall a snapshot. One other aspect of spatial audio I just want to touch on quickly is dealing with low frequency energy and other subsystems. And we deal with that with panLab console, again with another piece of technology that you'll be familiar with if you're familiar with panLab, and that is derived outputs. So a derived output is a bit like a spatialized auxiliary send, or you could even just think of it as like a post-fade auxiliary send, really. And essentially it's another set of outputs that we might want to send our sound objects to. So if I go back to the speaker manager, you'll see that we've got this option here to add derived outputs. So if I click on that, each panLab console file comes with 8 possible derived outputs. So we're going to create 2 today. We're going to create a front sub and a rear sub derived outputs. So let's just type those out. And again, we're just linking it to console output channels. So if I select here, the last 2 available channels on this particular console are already labeled front sub and rear sub. So I'm just linking those 2 together, and I can assign them. And essentially, I just need to assign which channels I want this output to be derived from. So it means if I'm sending audio to one of these outputs because of the way it's spatialized, we're also going to be sending it at that level to the sub output. So this is our front sub, so I can tick all of our front loudspeakers, so that's our main array, and also maybe the front overhead speakers. And then for our rear sub, I can assign that to the surround speakers and the rear overhead speakers. So let's hit done on that. And now for each individual source on the panner, we've got these two faders here labeled front sub and rear sub. So I can turn these up to 0. And you'll see that at the moment our drums are on stage, so they're completely just being sent to the front sub, which is on bus 15 down there at the bottom. And if I was to move these drums back into the auditorium, that you'll see that the energy is now being distributed more towards the rear sub, until when I move the drums all the way to the back, all of the drums are now being sent to just the rear sub and not the front sub. So we can spatialize quite quickly where, any number of subs, well, actually say any number of subs, up to 8 subs you could spatialize, but you could put, quad subs in this space and spatialize the sub 4 ways instead of 2 ways. You could also use these derived outputs to do things like create a left-right down mix of your spatial audio mix for archive purposes. You could use it to create sort of delay lines or any kind of other subsystem that you might want to create and apply to your spatial audio mix. So last thing I kind of want to show you is some of the ways that we're incorporating working with external tools via OSC, MIDI and timecode. So if I pull up QLab onto the main screen here so you can see it, you'll see that I've got a few OSC cues set up, so just to make things a little bit easier. So what we'll do is just make panLab console a little bit smaller so we can see both pieces of software. Even smaller. Cool. So every object that you can automate in panLab console has a property that we call the recall ID, and that will need to be a unique letter or number sequence. So it's a string essentially. By default, we assign numbers starting from 0, but you can edit that to make it more human readable. So I could put drums on the end of it if I wanted to. You can actually use OSC wildcards to group, channels together and control multiple channels at the same time, should you wish. But this recall ID here is really critical, and it's the way that we're actually interacting with those objects externally. So if I pull up the documentation. So this is the live documentation. So this is the original OSC dictionary. This is all going to be updated with version 1.1 with many more commands. But you can see we can do things like recall the position of an object via OSC or the level of an object, and we can do things like recall snapshots and sequences via OSC as well. So what have we got set up here? So our drums object here is at recall ID 0. So in QLab, we've got the string panLab console /source because we're addressing a source /0. That's its recall ID, and position and the 3D coordinates of the position. Let's get rid of that 4th coordinate for now. I'll explain that in a minute. But with this, for example, 0.5, 0.5 will essentially move the drums directly to the middle of the panner, just like that. We can also add in a 4th argument, which is the duration time of the move. So I could put 3 seconds in and then move my drums somewhere else. And just with this one command, the drums will now automate over 3 seconds to the middle of the space. I can do things like draw vector paths in QLab, should I wish, and automate the drums over that vector path as per QLab's outputs. I can also recall sequences via OSC. So this network queue is actually panLab console sequence 0 recall, which should recall our guitar going around, if I remember rightly. Let's just stop that for a minute. What else can I do? Oh, I can recall snapshots as well. So if I, again, so it's the same terminology, snapshot, panLab console snapshot 0 recall will now recall that first snapshot because it also has a recall ID of 0. And what's the last shot? Oh yeah, snapshot 1 recall. So again, so I can address that specific snapshot and recall it remotely via OSC. I can also recall loads of properties via MIDI. this is a new feature for version 1.1, which is, as I said, yet to be released. But now you've got this additional little icon, which is our kind of MIDI setup icon. And you can map any of the properties of the source, like the X, Y, or Z coordinates, to MIDI. So if I hit the capture button here and go over to my MIDI list and send a MIDI note, for example, this MIDI note is going to be mapped to the X position. So MIDI note 61, the velocity value would be mapped to the X position, which is actually kind of a bad example. What I should do is the next one for that, which is a control change, because then in QLab I can automate it. So now a control change is going to be the X position. And if I say in a fade over duration, you can see that it will move my lead singer all the way to the left over the fade time that I've just sent that from QLab. Or I could turn that off. So now it's just going to be sending value 64 and it will just move our object to the middle. So there's a whole heap of MIDI controllers out there that you can use in a creative way to move objects around. Which brings me back up to a load of new functionality that we've built around OSC. So with version 1.1, which this is just really hot off the press that I've just been working on in the last few days. Sorry, just take a drink of water. We've now got two-way bidirectional communication via OSC. So we can, this is Touch OSC, which is another piece of software on the right, and it's sending OSC commands to panLab console, but also panLab console is able to update position of objects via Touch OSC. We've got this slider here which moves things on the height axis, which is kind of cool. And also we're able to subscribe to the state of objects. So we've got this kind of concept of creating a subscription to an object so that our panner can just be interested in receiving updates on the bass, as an example. Or if I change this little toggle here, it's going to just receive updates on from the drums. As an example. And also these, even just the name of the channel is being live pulled in from panLab console, so we can, you know, just get live dynamic updates on all properties from panLab console over OSC. So I kind of feel like that's a pretty broad introduction to the software, which I hope you're excited about and you like. And so probably at this point, I could open up to questions. I've not been monitoring the chat myself, but potentially, Lindsay, there's some questions in the chat.
Yes, we have one from Adam Mendelson. Can you edit the pathway?
You can edit the whole pathway at the moment. So you can edit the whole thing. So you can just move the whole thing around, which I showed. But I'm guessing you mean, can you edit like the individual shape of it? Not right now. So that's going to be an additional feature that we're going to be working on. Two things I want to be able to do with it. One is smooth out the movement. So that we've drawn roughly a circle here, but I want to give you a slider so that kind of morphs into a much nicer looking circle. And also potentially, add sort of paths on that you can kind of pull in and edit it in a more creative way. That is going to be coming down the line in the next couple of months. But at the moment, you can move the whole object around on an axis.
I have a comment here from Kevin McCoy. It says, this is extremely cool. Also, kudos for making a very intuitive UI. I really felt like I could have been sat down in front of this software and set it up in 5 minutes, even without this demo, although I'm very grateful for this demo.
Thank you. That's great.
Adam Mendelson has a question. Can you show us how to sequence in 3D, i.e. something flies over the top?
Sure, let's do it. So let's make our lead vocal fly over the top. So first of all, we can pan down to the side. So we're looking at things from the side. And when we're at the sides, so when I don't know if I explained this actually, when the background turns gray, we're moving on the height axis. So we can move objects up and down on the height axis. When the background is black, then we're moving on the XY axis. So again, I've just tried to make it intuitive. you're always panning the camera around a central point of origin, and you've kind of got a clear visual representation when you're working on one axis or the other. So let's say we wanted to move our lead vocal up and down. Now, because we're looking at this axis, we're basically looking at whatever plane we're looking at the panner on, plus the height axis. So if I hit add a sequence and get that object to come up and down, essentially that's what it looks like in 3D space. It looks like a kind of rocket that's slightly gone wayward and started flying again. So yes, so you can create that path, and that those vocals will shoot up and down.
Amazing.
Thank you.
Mike wants to know, can you show some uses of delays such as mains and balcony?
Sure. So how would I do this in a spatial environment? What I'd probably do is derived outputs. So let's set something up. Well, first of all, you could obviously do this with an external processor if you wanted to. So if you were running all these outputs ultimately through an external processor, you could essentially create a derived output or a subsystem in that processor. If you wanted to do it in panLab console, let's go back to the speaker manager and go to assign derived outputs. Let's say we've got under balcony fills, that might be there. Oh, I've actually run out of output channels. So let's commandeer that rear sub output channel to allow us to do it. And what would we want to assign from there? So if we're under the balcony, we might just want the main proscenium system, I guess. Maybe would you want the overheads in it? I guess you could set that up however you wanted. So let's say we wanted a subsystem of just a derived output from what we've put into the main kind of proscenium system. You do it like that, I guess. And what you can actually do is you can actually edit multiple sources at the same time. So if I drag and select all of these sources, now I can actually turn this under balcony fill up for all of the sources, and not just one source, but I'm actually editing all of them and setting this under balcony fill for all of the sources on the panel because I've selected all of them. So that might be how I do it.
Great. And Mike has another question as well. What is best practice when your main speakers are flown? Do you show sources on that level or below?
Good question. And I kind of thought about that because actually the example I gave here doesn't quite work for that because I've got these overhead speakers, but I'm also kind of thinking that these are flown speakers. I wouldn't be too strict about it. I'm thinking more in terms of a logical group of speakers that you want to pan a sound around. So typically, like if you think about a very generic theatre pros where you'd have three levels, say a orchestra and then your circle levels, quite often I would actually group those three proscenium speakers together. So essentially we've got one send to, the left stack and one send to the right stack, and then you group those with your surround speakers on each level. Like when you're looking at the height axis, it's kind of got its uses, and I put it into this example because I wanted to show it off, and it seemed like a good place to do it. But in actual fact, in standard theatre, it's a bit trickier than that because you've got audience on multiple levels. The height axis comes into its own more in sort of immersive environments where you've got the audience on a ground level and you've got actual literal height speakers or something like an immersive art gallery, for example. In theatre where you've got audience at different levels, it's a bit more tricky really to work with height, to be quite honest with you.
Dan Jaquette is interested. Can you walk me through some connectivity questions? Can we look at network settings tabs in QLab to understand OSC connection between QLab and panLab console via localhost?
Absolutely. So let's do that right now. So obviously at the moment, this is just localhost. So in panLab console, if you go to the panLab console menu and go down to settings, you can set the OSC port that you're receiving on. So obviously you'll need to know the port and also the IP address of panLab console in order to be able to connect to it. So the generic port, the standard port is 5300 for panLab console. So that's probably what it is, unless you've changed it. So we hit done on there. If I go over to QLab and go over to my workspace settings and my network tab, you see that I've just created a generic UDP network patch that's on localhost because I'm on the same computer. And I'm setting it to port 5300. panLab console will actually work on either UDP or TCP, so that doesn't matter. It will work just the same, essentially both ways. But yes, you'll just need to know the port number that you see in QLab, in panLab console, and then you'll need to set that in QLab or in whatever software or hardware you're using to send OSC. I'll do a lot more documentation for the newer protocol, but essentially it works it's got the same kind of style as QLab. So if you send, in fact, I can publish this TouchOSC template and people can just use it. But essentially, if you send a command without any arguments, so if I just sent /position as an example, then you'll receive a reply with the exact position. And if you do send arguments, then you'll be updating that object. So it's it's just supposed to be quite a simplistic way of interacting.
Great. Do we have other questions from folks out there? Oh, yes. Adam looks like he's got another.
Yeah, I was trying to type it, but it was taking me too long.
No problem.
So it's a very cool product. And I just wanted to thank you again for it, as a lot of people in the chat are saying. I have a specific use case. So I'm thinking about something that flies around, both like like this and up and over. And so that would be like two sequences sort of combined, right? The one that's in a horizontal plane and one's in a vertical plane. Okay, great. Thank you.
Yeah.
And when you create that, do you create one and then connect it to another, or is it you're doing it simultaneously?
Yeah, good question. So yes, you definitely could do that. So what I would be doing if I was creating that sequence, first of all, I'm very hopeful that we'll be able to add the sequence functionality so you could do all that in one sequence. At the moment, the sequence just works on one plane, essentially. But obviously, we just need to add some editing functionality to that. But if you did want to have the functionality, use it as it was at the moment, then essentially you could just trigger your first sequence and then work out the time, the duration of that sequence, which is just given to you on the screen here, and then that much time later you then fire your second sequence. And in fact, any time that you ask an object to do two things, it's always the last command that takes precedence. So if you had fired one sequence and halfway through that sequence you want it to do something else, you just fire that second command and it just goes, all right, we're not doing that first sequence anymore. We're doing whatever you've just asked me to do. So yeah.
Awesome.
I've got one more slide, which is I always do a little like a little thank you slides, and we just always do like a discount code for coming to see the webinar. And feel free to, I don't actually get the email addresses of people who signed up, but if you want to distribute this to members of TSDCA, be my guest. But yeah, so in fact, it's any software on the website for the next week or so, however long that is, you can get a 20% discount if you wanted to go ahead and buy it using that discount code. So thank you so much for coming and finding out a bit more about this product. Thank you.
Awesome. Dan, thank you so much for staying up late with us. We really appreciate this. This is really exciting. So we'll be posting this video on our website for people to view. If you want to review any of this in the future, we'll have it up in the next couple of days. And if you have any other questions that arise after this, feel free to write info@tsdca.org and we can pass your question on directly to Dan, who can help you out. And yeah, again, thanks so much for being with us. Feel free to visit tsdca.org to learn more about us. And hopefully we'll see you again soon. Dan, thank you again. We really appreciate it.
Thank you. I really appreciate you guys having me. Thank you.
All right. Take care, everyone. Thanks for being here.
Cheers. Bye-bye.
Bye.